Hello everybody. In this video, we'll present the major improvements for STRAP 2018. The design process of wall elements was reorganized and improved extensively. Design units consisting of multiple segments can now be defined by the user. Different units can be defined for bending and for shear. Results are displayed and reinforcement is being calculated for every design unit. Wall drawings were majorly improved. Additionally, the user may ask to draw hoops around the concentrated vertical bars. Beam detailing drawings that were done by bar PLT software can now be added to the drawing in Concrete Postprocessor. The user may also include beam sections made by bar PLT. For models that are located in a network drive folder, the program will automatically copy the relevant files to a temporary local drive folder for calculations. Let's see an example of defining a temporary local folder. From the Models tab, go to Setup, Miscellaneous, and the Network tab. Select the second option that will allow the program to run the calculation on a temporary local drive. The Browse button will allow the user to select the temporary local folder. When working on a model located on a network drive folder, the relevant files will be copied to the temporary local folder for calculations. When the user exits STRAP, the files will be copied and updated in the network folder automatically. STRAP users can now create multiple drawings in the Loads module. In the Loads module, go to Output, Create Multiple Drawings. The user may set the drawing view by selecting Saved Views or Levels and select the relevant load case. For load cases groups, we added an option to define a load case group that all loads in it will be multiplied by a factor. When generating a load combination with this group, the program will generate a number of combinations that equals to the number of load cases in the group, and the factors defined in the combination table will be assigned to each of the load cases with every combination generated by the program. In the following example, we'll define a group of 3 imposed load cases and define a load combination according to the following formula taken from the Eurocode. We can see from the formula that we need to assign a different factor to each imposed load case. To define the load groups, in the Results module, go to Combinations, Groups, Add Revise a Group. Name our group and include all 3 imposed load cases. Now we'll select the third option, a different combination for each load in the group, together with all other group loads multiplied by a factor. We'll insert a factor of 0.75. Now we'll define the combinations. Select Define Revise, and for our permanent load group, we'll give a factor of 1.35, and for the imposed load group, a factor of 1.5. Let's see the combinations STRAP created. We can see 3 combinations. In every combination, one load case from the imposed group got a factor of 1.5, while the other loads get a factor of 0.75. STRAP can now handle punching calculations of inclined columns up to 25 degrees. In the following example, the columns are inclined at 12.5 degrees relative to the slab. In the results module, we'll go to punching and ask to see the punching results. We can see the results for inclined columns. In steel postprocessor, pipe sections can now be designed according to the resultant moment. In steel postprocessor, go to defaults and check the line compute pipes for resultant moment. As well known, in steel postprocessor, the user may define parameters and assign them to a specific beam member. Now, when we display the data table, a change in a parameter value will be colored in red. Let's see an example. We'll change the allowable deflection of member 57 to L divided by 300. Additionally, the user will be able to restore default parameters value. Select Parameters, Restore Default. Select the parameter type and select the beam member. We can see that the allowable deflection for member 57 was restored to default. The user may now define a unidirectional distribution of a global load and apply it to beams. Let's see an example. For the model on the screen, we will define a new load case. Select Global Load and define. The load type will be an area load, and x3 is the load direction. The load is minus 0.3 tons per square meter. At Apply Load As, we'll select the new option, Unidirectional Distribution, Beams. We'll define the load contour and select to distribute the load at x2 global direction. Let's check the load distribution. Go to Display, Global Loads on Beams, and select Display Load Area Distribution. We can also see the load distribution as beam loads. Go to Display, Global Loads on Beams, and select Display the load as a beam load. The following tables were added to the Dynamics module: effective model mass, MMI and mass center, and mode shape at level mass center. A wireframe display option is now available. To access the display from the Geometry module, we'll go to Display, Wireframe. After we selected the wireframe display, the Render button will display wireframe. To go back to a render display, we'll select Display and Render. Restraints display options were added. Let's see an example. In the Geometry module, go to Display, Restraint Display Options. We'll check the second option, Node Number. We can see the program display only the node numbers of the restraint nodes. The user is able to control the display size of text and the restraints. From the Models tab, go to Setup, Miscellaneous, and the Additional tab. Under Screen Graphics are the parameters for text size and restraint symbol size. The user may include the column section size in the General Arrangement display. Go to Draw, General Arrangement Parameters. Under Display Sections 4, we'll check Columns. Assigning property equals 0 while defining a beam member will assign the beam a dummy property. Let's see an example. In the Geometry module, select Beams and define. Assign property equals 0 and select 2 nodes for beam definition. The UI of the EDDraw module was redesigned and larger toolbar icons are now available. That's it for this video. Thank you very much for watching.